Assignment 1-6, position, velocity, acceleration. Here we go. So in question number 1, you're given the position equation, and it's moving in a straight line, and then there's questions. So the first question has to do with velocity. So how do we find velocity? Is take the derivative of the position. That's 12t squared plus 6. In part B, find the velocity at 2 seconds. So if you plug in 2 seconds into here, what is that? 48 and 6, 54, right? And make sure that you have units for this one. So in the question it says it's meters and seconds. So that's meters per second for velocity. Find the acceleration of the function. That's the derivative of the velocity. That's 24t. Find the acceleration at 3 seconds. So then we plug in 3. 72, and make sure that we write acceleration properly. So acceleration is written as meters per second squared. It is meters per second, the change in velocity over the change in time. When is the velocity of the particle 18 meters per second? So we're going to take the function and make it equal, take the velocity, and we're going to make it equal to 18. Subtract 6, divide. So that would be positive and negative 1. And the unit is in seconds. If it was a real world situation, not something conceptual, so an actual something on a cliff or something, then time would only be positive. But conceptually speaking, we can have negative and positive time. Find the velocity when the position is 25. So the position is 25. So we make it equal to the position. Oops, it's 2.5. I'm going to use my calculator to solve that. It doesn't feel like I want to do that without a calculator. So how do I solve this with my calculator? Let's see if I can get it so there's no shine. Go menu, algebra, and solve. And then we're just going to type it in. So 25 equals, we can use t, 4t cubed. Oops, let's try that again. So 4t cubed plus 6t plus 2.5. Now make sure you go comma t. That tells the calculator to solve for t. And then you get the answer, which is 1.5. So at 1.5 seconds, the velocity is 25. F, oops, that wasn't the end of the question. Now it says, what's the velocity at that time? So now that we know the time, we first have to figure out the time. Now we can plug in 1.5 into the velocity. Again, use your calculator. So just type it in, and if you did it correctly, you would get, 33. And make sure you write down the units correctly. G asks, find the initial position. So you take the position equation and plug in 0, and so you're left with that, and the unit is meters. H asks for displacement. Now displacement, we just have to find the difference from where you ended and when you started. So you plug in 1.5 into the position, you plug in 0 into the position, and then you calculate it with your calculator. And if you did it correctly, you would get 22.5. So again, use your calculator, plug 1.5 into here, type it in correctly, get an answer. 0, we already know that's 2.5, and then do the work. You can do that, and it's 22.5. All right, number 2. Helium balloon rises so that its position is given by this equation, t squared plus 3t plus 5. And again, because it's a real-world situation more, they're saying time is greater than or equal to 0. The first question is, when is the balloon 45 feet high? So we need to make it equal to 45. and then solve it. Now for this one, we can subtract 45, and it is factorable. So it's good practice. You need to do it. What are two numbers that multiply to negative 40? And the same two numbers add to 3. So that's good practice. Something simple. So when I solve this, this will give me a negative answer. So the positive answer is at 5 seconds. B asks, how fast is the balloon rising? That's same as asking about velocity at time equals 1. So the velocity I need to find. That's 2t plus 3. And then once I know the velocity, you're going to plug in 1, and you get the answer 5. And again, the units, what do we got? Feet and seconds. So that's feet per second. C, how fast is the balloon rising at 4 seconds? So again, we're going to use velocity and plug in 4. So that's 8 plus 3. So that's 11 feet per second. Nice and simple. D, what is the balloon's velocity when it's 45 feet high? So when it's 45 feet high, I need to know the time. So 45 feet high is the position. We did that one already, right? So at 45, at what time is it? So first 45 feet into the position, we did it. It's at 5 seconds. So then I plug in 5 seconds into the velocity, and it's 2 times 5 plus 3. So the velocity at that time is 13 feet per second. All right, turn the page. I don't think I'm going to finish the assignment in one video. So this is going to have a couple parts to it. But here's part 1. A ball rolls on an inclined plane with position. So here's the position of it as it's rolling on like a ramp. So I'm writing that down. And then it's in centimeters and seconds, just to know the units. Find the ball's velocity at 2 seconds. So to find velocity, we take the derivative. And then once we have that, then we plug in at what time? 2 seconds. So then you plug 2 in and make sure you have the correct units. So 4 times 6, that's 24 and 12. And then the correct units. So that's centimeters per second. B, when is the velocity of the ball 30 centimeters per second? So the velocity is 30. The velocity equation is 6t squared plus 6t. This is factorable. So I'm going to make it equal to 0. If it wasn't, I'd let you know, and I'd say use a calculator. Divide everything by 6. Oh, it's not factorable. I thought it was going to be factorable. You need a calculator. So let's do it with our calculator. So take out your calculator, press menu, press algebra, and solve. And then we're going to type it in. So we're going to type in, I'll use t. So t squared plus t, subtract 5. Equals 0, comma t. So this is what it looks like when I type it in. Go control enter. We only want a positive time. They both are positive. No, one's negative and one's positive. So we don't want the negative time, and it's a real world situation. So I'm only going to write down the positive time. So 1.791. I'm 100% positive on an AP exam. They would tell you if this is true, in terms of that. What's the next one? Number 4. The graph at the right shows the position of a car over time. So like where you started and so on. It says what was the car's initial position? So you can see the initial position is at 0. B says, was the car going faster at A or B? Which one's steeper? And if you drew a little line at that point, you could see A is steeper. That means the slope is greater. Was the car speeding up or slowing down at B? So what does that mean if it was speeding up or if it's slowing down at B? So if you look at this, look at what's happening around it. Do you see that the slopes are getting less? So it was speeding up, and then at B, it starts to slow down because the slopes are flattening out. So it is slowing down. And again, we're looking at the slopes and if they're getting greater or less. In this case, the slopes were getting less in size. What happened between C and D? So between C and D is horizontal. So that means between C and D, the car rested, stopped. So when the position doesn't change, that means the object, or car in this case, rested or stopped. All right, number 5. In number 5, I'm just going to read it. A particle moves along a horizontal line. The position is this. T cubed subtract 3t squared. Again, we have centimeters. In this case, minutes. So it's good to know the units. Find the particle's displacement between 5 and 0. So take the position, plug in 5, take the position, plug in 0. It's okay to use a calculator. So if you plug in 5, you get 50. If you plug in 0, you get 0. And for displacement, it's just the unit in terms of that. So the displacement is 50 centimeters. So where you started to where you ended, you went 50 centimeters to the right. B, find the particle's velocity when t is 4. So to find velocity, we take the derivative of position, and then we plug in 4 minutes. So this is 48, take away 24. $16 and 3, right? 48 take away, make sure I'm looking at the right thing. Yeah. So it's actually 24. So 48 take away 24 is 24. And that's centimeters per minute for the correct unit. For C, was the car speeding up? No. C, find the particle's acceleration at 4. So the acceleration is the derivative of the velocity. That's 6t subtract C, 6. At 4 minutes, plug in 4. And it's 24, take away 6. And that's 18. Now, how you write acceleration with these units is centimeters per minute squared. That's how you write it down. It's centimeters per minute per minute. D, at what time does the particle change direction? So to understand that, we need to take the velocity equal to 0. We need to know when it's at rest. So 3t squared, subtract 6t, make it equal to 0. Factor out 3t, and you can see the two answers are 0 and 2. So when I draw a number line, in this case, this is a conceptual question, so time can be from negative infinity to positive infinity. Put those two numbers on a number line, 0 and 2, and now we have intervals. So pick any number smaller than 0 and plug it into the velocity. So if I plug in -1, I get 3, a negative times a negative. All of this is positive, so you get a positive answer. If you plug in a number between 0 and 2, like 1, if you plug 1 into the velocity, you get a negative answer. Again, I'm not focused on the actual number, but whether the answer is positive or negative. Plug any number bigger than 2, so like 3 gives you 12, take away 18, so that's a negative answer. So, let's try it again. So plug in 3, silly me, that's 9 times 3, that's 27, take away 18, so that's a positive answer. We can also understand this is the multiplicity. So if it has an odd exponent, the sign's going to change. So at 0, the sign's going to change. So if we know 1, we know the sign's going to change. And then again, an odd multiplicity, the sign is going to change again. That's a helpful tool to be able to get through the number line more efficiently. The question for D was, what time does it change direction? So if I don't do all of them, there needs to be a sign change in order for it to change direction. So this is when, and it's in minutes, right? This is when the particle changes direction at 0 and at 2. E, it's good that we have this because we're going to need it for E. For E, it says what's the total distance that's been traveled here. So between when? Oh, 0 and 5. So if I just look from 0 to 5, in between we change directions at 2. So make sure my signs are correct. The total distance is understanding this distance and then understanding this distance. So to find distance, you plug it into the position function, 2 and 0, and subtract. It's going to be the absolute value. So it's okay to use a calculator or not. You're just plugging it into this. So plug in 2. So if you plug in 2, you get the answer -4, but we're going to make it positive. We're going to do the same thing for 5 and 2. Now know, because you're going to the right, this answer is going to be positive. So you don't need the bars because they're going to be positive. This number is 54. Again, we're plugging this into the x equation, and then you add them together, and the total distance traveled is 54 centimeters, right? Is that what we're in? Yeah. So that's the total distance. But we need to know what direction, and if there's a change in direction, what's the distance to the left? What's the distance to the right? You find that by subtracting using the position function, and then you add them as positive numbers, and that gives you total distance. F, find the particle's average velocity, that's AROC, between 0 and 5. So that would be, this is AROC, it's y2 minus y1, and then x2 or t2 minus t1. That's just slope, like using algebra. We just did this one, didn't we? From 5 to 0. Did we just do that one? Maybe we didn't. So from 5 to 0, plug in 5 here. 0 gives you the answer 0. So plug in 5 and you get the answer 50. And then divided by 5, and so the average velocity is 10 centimeters per second. The last one is find the particle's average speed between 0 and 5. So for the average speed between 0 and 5, we would use the total distance and divide it by the time. So the average speed, we would use the total distance from 0 to 5 and then subtract. So the numerator would use the total distance and then would have the same denominator and then divide it out. So the average speed then would be 58 divided by 5. You don't even need to simplify that down. But notice for speed we use total distance, and for average velocity we use displacement. Two different things. Alright, number 6. See if I have time. This is probably my last one for this video. The graph at the right shows the velocity of a function. When does the particle move left? So for velocity, it moves left when it's negative. So I need to know when is it negative here. To do that, we need to know what the x-intercept is there. So the slope here is down 3 and to the right 1. So I'm going to write an equation first for that. And the y-intercept is 1. So negative 3t plus 1 is the equation of that line. If I make it equal to 0, oh wait a second, it went down 4, didn't it? Let me look again. So the slope is 1, 2, 3, down 4 into the right 1. So there's the slope and the y-intercept. I want to know the intercept, so make it equal to 0. So you're going to add 4t and divide by 4. So without doing that, I can't just say it kind of looks like you got to do some math to understand it. And so to begin with, from negative a quarter where else, when does it stop being below, is right here at 7. So from negative a quarter to 7, it's moving left. Next one, that's A. B, when is the particle's acceleration positive? So the particle's acceleration is positive when it's above and it's a positive slope. So from 7 to 8. Oh no, let's just try that again. So the particle's acceleration is positive when the slope of the velocity is positive. So from 4 to 8, it is speeding up from where it is. Now it still might be going left, but the acceleration, we're looking at the positive slope. So this is velocity. The derivative or the slope of velocity is acceleration. So where is there a positive slope? And that's from 4 to 8. That's what we're looking at. And then C, when is the speed the greatest? So speed is the absolute value of velocity. So here we have the answer 1. Down here we have the answer -3. But the absolute value of that makes it +3. And that's when the speed is the greatest. So when is the speed the greatest? Between 1 and 4. And to remind yourself, that's the absolute value, right, of velocity. So we're just changing the negative to a positive number. When does the particle stop? For more than an instant. So when it just crosses, it stops for an instant. When it crosses, it stops for an instant. But when the velocity has 0, this is acceleration. So here, when the velocity is 0 for more than an instant, between 9 and 10, the particle has stopped for more than an instant. All right, that's going to be it for this video. Mr. G Math over and out. Proud of you that you're doing your work. And until next time, we'll do the next video real soon to continue the assignment.